Welcome to Brain Vision.
All right, guys, in order to answer this question, we are given the following data for two rooms with oxygens. We have TA is equal to 15 degrees centigrade, that is equal to 288.15 Kelvin. We've got TB is equal to 60 degrees centigrade, that is equal to 333.15 Kelvin. And then we've got T2 is equal to 20 degrees centigrade, that is 293.15 Kelvin, and we've got PA is equal to 300 kilopascal. Then we have PB is equal to 500 kilopascal, and then we've got MB is equal to 4 kg, and we have VA is equal to 1 cubic meters. So the energy equation for this problem is Q is equal to M2 into U2 minus MA into UA minus MB into UB plus W. So this is constant volume process. So the work done is equal to W is equal to 0. Now heat transfer is equal to Q is equal to M2 into U2 minus MA into UA minus MB into UB. So the from ideal gas equation we can calculate heat oxygen mass in room A, that is PA into VA is equal to MA into R into TA, and MA is equal to PA into VA divided by R into TA. So guys, from table corresponding to oxygen, we've got the value of R is equal to 0.2598 kilojoules per kg. So MA is equal to 300 into 1 divided by 0.2598 multiplied by 288.15, and that is equal to 4 kg. Now from ideal gas equation we can calculate oxygen volume in room B, that is PB into VB, and that is MB multiplied by R multiplied by TB. So we've got VB is equal to MB multiplied by R multiplied by TB over PB. So now putting the values, we have 4 into 0.2598 multiplied by 333.15 divided by 500, and that is equal to zero point 0.7 cubic meters. So the total volume of room A and B is given as V2 is equal to VA plus VB is equal to 1 plus 0.7 1.7 cubic meters. So we've got M2 is equal to MA plus MB is equal to 4 plus 4 is equal to 8 kg. From ideal gas equation we can calculate the final pressure, that is P2 into V2 is equal to M2 into R into T2. So we've got P2 is equal to M2 into R into T2 divided by V2, and that is equal to 8 multiplied by 0.2598 multiplied by 293.15 divided by 1.7, and the answer to P2 is equal to 358.15 0.4 kilopascal. Now the heat transfer, guys, that is equal to Q is equal to M2 into U2 minus MA into UA minus MB into UB, and we can write it oxygen using heat capacity instead of internal energy. So we've got Q is equal to MA into CV multiplied by T2 minus TA plus MB into CV multiplied by T2 minus TB. And from properties of ideal gas table, we can find heat capacity as CV is equal to 0.662 kilojoules per kg Kelvin. Now we can substitute our values and we obtain Q is equal to MA into CV into T2 minus TA plus MB into CV multiplied by T2 minus TB, and that is equal to 4 into 0.662 multiplied by 20 minus 15 plus 4 4 into 0.662, it's 6, 4 into 0.662 multiplied by 20 minus 60 multiplied by 20 minus 60. So guys, the answer to Q is minus 92.6 kilojoule. So guys, we have the value of P2 and Q. These are the answers to this question. I hope you have easily understood all the calculations and the formulas. Thank you very much.